A week ago from when I'm recording this, India landed their Chandrayaan 3 spacecraft on the south pole of the moon, which is a huge accomplishment considering they're only the fourth nation to have landed on the moon itself. Since 2003, about 20 years ago exactly, the Prime Minister of India announced the project, the Chandrayaan project, on course in his Independence Day speech. This mission was supposed to be a huge boost to India's space program because it was one of the first times that India was looking away from just sending satellites into space and more towards grounded achievements that would make India's space program one of the most renowned in the world. The Chandrayaan mission was composed of three different parts so far. Chandrayaan 1 was an orbiter and impactor that first orbited the moon and then it impacted the surface. And in this, it was able to discover water on the moon, traces of water on the south pole of the moon, which was a very big deal because water could be used for many different things in terms of a lunar base or anything of the sort. First of all, because water can be used for life support for humans, but also because the hydrogen within water and the oxygen could be used for things like HNO or oxidizer, different types of fuels that could be used on spacecraft. And so basically, just the discovery of water and the potential for that to be there on the South Pole was a very big deal. And India, having discovered this, decided to go further with this mission and actually be able to land on the moon to find if those traces are actual discoveries of water rather than just the suspicion of it being there. In 2008, Chandrayaan 2, the successor to Chandrayaan 1, was approved, although it was postponed for many, many years. For example, it was rescheduled to 2016 because Russia was not able to develop the lander that was supposed to be used on Chandrayaan 2 in time. Russia later withdrew in the wake of the failure of the Phobos grunt mission to Mars because of some technical aspects connected with the mission that were also used in the lunar projects. And after Russia cited this inability, India decided to develop the mission independently, the lunar lander independently, and any of the unused orbiter hardware that they had created prior to Russia pulling out of the project was repurposed for the ISRO's first interplanetary mission, which was the Mars orbiter mission. So Chandrayaan 2 was launched on the 22nd of July 2019 on an LVM-3 rocket, and it was successfully put into lunar orbit on August 20th, but the lander, the Vikram lander, was lost while attempting to land on the 6th of September. The orbiter, though, is still operational even now, and it has continued to collect scientific data and will function for about 7.5 years after its launch. In November 2019, after the success of the partial success of the Chandrayaan 2 mission, the ISRO stated that a new lunar lander mission was being studied for launch in November 2020, and this proposal was, again, the successor to the Chandrayaan series, the Chandrayaan 3, and it would reattempt a landing on the south pole of the moon in partnership with Japan for 2025 with the Lunar Polar Exploration Mission. The Chandrayaan 3 space configuration didn't include launching an orbiter, and it only had a lander, rover, and propulsion module, costing the mission about 250 crore, with additional launch costs of 365 for the LVM-3. The third mission will land in the same area as the second one was supposed to, which was the lunar South Pole. And it was launched finally on the 14th of July, a month and a half ago. The mission encompassed three key aspects. First, to showcase a successful and controlled touchdown on the lunar surface. Second, to demonstrate the mobility of a rover on the moon's terrain. And last, to carry out scientific experiments directly on the lunar surface. And on 23rd of August, the Chandrayaan 3 lander, Vikram, was able to land successfully near the lunar South Pole region. So going into a bit more depth about the importance of the lunar South Pole region and why India was landing there, that region holds particular interest for scientific exploration because of studies that show large amounts of ice there that have been protected from melting from the sun because of mountainous terrain and unpredictable lighting conditions that exist around these suspected areas that contain ice. The ISRO's mission objectives for the Chandrayaan 3 mission were first to get the lander safely on the moon, then observe and demonstrate the rover's driving capabilities on the moon, the Pragyan Rover, and they're conducting and observing experiments on the materials available on the lunar surface, like the ice that is supposed to be there. So already, from the 26th of August, about 4 days ago, the ISRO confirmed that 2 out of the 3 mission objectives have already been accomplished, which were getting the Vikram lander safely on the ground, which was accomplished on 23rd of August, and then getting the Pragyan rover out and running, which has already occurred, and it's moving steadily at a rate of about a centimeter a second, driving towards the areas with suspected ice. So the Chandrayaan 3 mission used the LVM-3, which is India's 3-stage medium lift launch vehicle, made by the Indian Space Research Organization itself. It's primarily used to launch communication satellites into geostationary orbit, and it's due to launch crewed missions as well. So the propulsion module was designed to carry the lander and rover to an orbit around the moon of 100 kilometers. It was created like a little box-like structure that had a large solar panel mounted on one side and a cylindrical mounting structure for the lander, the Vikram lander containing the rover on top. It has a bit of a strange design, but the reason why is because the ISRO does not have the funding to create like sleek designs like, let's say, SpaceX does. Essentially, though, with the funding that the ISRO has, they're able to make creative and pretty ingenious designs that are able to cut costs, and even without the sleek look, they're still very efficient in what they can do. I mean, it's pretty obvious of their efficiency because they literally landed it on the moon and are now the fourth nation to have ever done that. So the Vikram lander itself is what was responsible for the soft landing on the moon. It's also box-shaped, just like the propulsion module is, with 4 landing legs and 4 landing thrusters that are capable of producing about 800 newtons of thrust each. So it also carries the rover and various scientific instruments to perform on-site analysis on the lunar South Pole region, or near the lunar South Pole region. So the lander for Chandrayaan 3 only has 4 variable thrust engines that have slew rate changing capabilities, unlike the Chandrayaan 2 lander, which had 5 of them, the 5th one being centrally mounted with only fixed thrust. Basically, one of the main reasons for Chandrayaan 2's landing failure was attitude increase during the camera coasting phase, which was basically removed by allowing the lander to control attitude and thrust during all phases of descent for the Chandrayaan 3 mission. The attitude correction rate was increased from Chandrayaan 2's 10 degrees per second to 25 degrees per second with Chandrayaan 3 to try and minimize the potential for disaster due to attitude increase. And additionally, the Chandrayaan 3 lander also has a laser Doppler velocimeter, or an LDV, that uses the Doppler shift in a laser beam to be able to measure the attitude in 3 different directions. The Vikram lander will target a more precise 4 kilometer by 4 kilometer landing region based on images from the orbiter high-resolution camera that was on board the Chandrayaan 2 orbiter, which was a successful part of the mission, and so is able to accurately assess the area much better than Chandrayaan 2 was, because Chandrayaan 2 did not have access to the same high-resolution images that now Chandrayaan 3 has. Generally, the ISRO improved the structural rigidity, increased polling in instruments, increased data frequency in transmission, and it also added additional multiple contingency systems that improve the lander's survivability in the case of failures during descent and landing. So the Pragyan Rover that is inside of the Vikram lander is 6-wheeled with a mass of about 26 kilograms. It's only about 3 feet by 1 1/3 foot in size. It's expected to take multiple measurements to support research into the composition of the lunar surface, the presence of water, ice in the soil, and the history of lunar impacts from meteors, asteroids, things like that, as well as the evolution of the moon's atmosphere, which is there. It has quite a small atmosphere compared to the Earth, but there's still a thin layer around it. The Pragyan Rover is designed to operate on solar power with the solar panel on one side, and it is intended to traverse 500 meters on the lunar surface at a rate of a centimeter per second, performing on-site analysis and sending the telemetry data back to the lander to be relayed back to the ISRO tracking stations on Earth. It's equipped with a stereoscopic camera-based 3D vision, which is basically 2 1-megapixel monochromatic nav cams on the front of the rover that provide the ground control team of the ISRO a 3D view of the surrounding area to help with path planning and generate a digital elevation model of the terrain. Now, the rover also has control and motor dynamics with a rocker bogie suspension system and 6 wheels that are each driven by independent brushless DC electric motors. Its power system has a solar-powered sleep and wake-up cycle that could result in a longer operation time than planned. The rover itself is only expected to operate for around 14 Earth days because its electronics were not designed to endure the frigid lunar night that would happen because of the moon's tidally locked nature around the Earth. So on the 23rd of August, the lander, approaching the low point of its orbit, fired its 4 engines in a braking maneuver at 30 kilometers above the moon's surface, and at around 11.5 minutes later, the lander was 7.5 kilometers above the surface, maintaining this altitude for about 10 seconds, and then stabilizing itself using 8 smaller thrusters and rotating from horizontal to vertical position while continuing its descent. Essentially, it made a hard stop midair for 10 seconds as it canceled out all of its horizontal velocity. In its descent, it used two of its four engines to slow its descent to roughly 150 meters, then hovering there for about 30 seconds as it located the optimal landing spot within that 4 kilometer by 4 kilometer area, then continuing downwards and touching down at 12:32 on the 23rd of August. So in terms of the scientific instruments that are on the Vikram lander and the rover, the Pragyan rover, they include Chandra's surface thermophysical experiment, also known as CHASTE, which will measure the thermal conductivity and the temperature of the lunar surface at the landing site. This one is attached to the Vikram lander. And also attached to the lander are the Langmuir probe, LP, and the instrument for lunar seismic activity, which will estimate the near surface plasma density over time and the seismicity around the landing site, respectively. The two scientific experiments on the Pragyan rover include the alpha particle X-ray spectrometer and laser-induced breakdown spectroscope, which will be used to derive the chemical and elemental composition of lunar soil and rocks around the lunar landing site and on the lunar surface, including things like magnesium, aluminum, silicon, potassium, calcium, titanium, iron. The propulsion module itself also contains a science experiment known as the spectropolarimetry of habitable planet Earth that will study the spectral and polarimetric measurements of Earth from the lunar orbit in the near-infrared wavelength range. I find the ISRO's decision to go with a slow mission rather than a fast mission pretty interesting, as in the orbits that the Chandrayaan 3 spacecraft made around the Earth before heading towards the moon, and even the orbits made around the moon to slowly decrease the apoapse of the spacecraft before landing. For example, Russia launched their lunar mission prior to India's Chandrayaan 3 mission in an attempt to land in the same region as the Chandrayaan 3 spacecraft, which would have reduced some of the prestige associated with India's landing. But the Luna spacecraft was not actually able to land on the moon, even while using the faster path towards the moon rather than making slow and steady course corrections on the way towards the moon. Just a few days before India's monumental achievement, Russia's spacecraft crashed into the moon, and it was lost contact. So essentially, the Chandrayaan 3 spacecraft had a perigee of 170 kilometers and an apogee of 36,500 kilometers in its parking orbit around Earth, which was done after several maneuvers to slowly increase the apoapse of the spacecraft before creating a translunar injection orbit. I think even though there's a lot of different accomplishments that we've already made in space travel and things like that, like going to Mars with probes and things like that, going to Venus, Mercury with the Bepi Colombo from ESA, I feel like what the ISRO achieved with their landing on the south pole of the moon is pretty incredible. More incredible probably than many of these other deep space missions. Even though there exists a difference with that, I think that with what the ISRO has in terms of funding and what they did with that is quite incredible. Right now, the Indian Space Research Organization only has a budget of about 0.04% the nation's annual budget, I believe, while NASA has a budget of about 0.24% of the U.S.'s national budget. And that difference is pretty crazy, but even more so when you think about how at NASA's prime, 4.4% of the U.S.'s national budget was used on NASA alone. And the ISRO at its height currently is only using a very tiny fraction of that. The Chandrayaan 3 project had an estimated cost of only around $90 million, which, considering things like SpaceX's missions and NASA's missions, the ESA's missions, what they were able to accomplish with such a budget is quite incredible. Post-landing, the ISRO was already able to release some one-of-a-kind data. With observation made by CHASTE, which was the thermophysical experiment on the Vikram lander, the ISRO was able to release first-of-its-kind data. The data showed a very sharp difference in temperatures above and below the surface of the moon. The temperature variation just above and below the surface of the moon was very steep, with a graphical plot put out by the ISRO that showed that while temperatures on the surface were over 50 degrees Celsius, they dropped to negative 10 degrees Celsius just a few millimeters below the surface, which essentially means that the topsoil of the lunar surface is not able to conduct heat very well and insulated the subsurface from heat. In its first ever in situ measurements, the Pragyan rover was able to detect sulfur, picking up signals that confirm the presence of sulfur, yet the direct evidence is not available yet. Apart from sulfur, LIBS was also able to detect elements like calcium, chromium, titanium, manganese, silicon, oxygen, aluminum, and iron. Also searching for hydrogen. I think what the ISRO did is really incredible. And I mean, it might be possible that India is currently overtaking Russia in its importance in space. Currently, the US and China are at odds with getting to the moon and being able to establish bases um, and orbital stations, but India seems to be a rising power in this race, and I feel as though coordination between between ESA, ISRO, and NASA would be really impactful in human exploration and development in space. I think it would be an amazing thing to be able to see these three organizations go further in achieving objectives like landing people back on the moon again for the first time, putting them near the lunar South Pole in the case that water is ever found, and being able to establish permanent bases. I think there are many different possibilities that could come from coordination with ISRO, and I believe that these successes could be further replicated